So far, I just assumed the existence of a table in order to do a simple example, and I didn't say anything about where that table came from, why it has the columns it has. So the next thing we're going to talk about is how do you get that to happen. We're going to do, our discussion of databases is going to be around migrations, which is something that in other programming frameworks is maybe not as popular. I think Rails really kind of put this on the map in a way that made it accessible to a lot of programmers. So the problem we're trying to solve here is that once your app is actually up and running, if it's an app that anybody cares about, the people who use it, they think of their data in that app as being pretty important. So you don't want to mess it up when you're experimenting or developing a new feature that might require a change to the database schema. And when you do change the database schema, you want to track those changes. I mean, obviously, you'd be a fool if you were developing your code files with no version control, right? No ability to sort of roll back to an earlier version of your code. So why wouldn't we think the same thing is true about the database schema? And the answer to managing both of these things is automation, as evidenced by the friendly dancing robot. In general, if you can automate something, it means that you can do it consistently. And we're going to come back to this theme again and again and again. Almost every successful thing that you do in software engineering at some point relies on automation to take some of the stupid mistakes out of it. In fact, when we talk later about deployment, I came back from a conference literally 15 minutes before class today, and there was a really, really great talk from somebody who runs the back ends of one of these games servers. And he actually used the phrase, deployment should be a non-event. Releases should be a non-event. And database schema changes, a little bit harder, but we're going to try to make them a non-event by automating them. So the way Rails addresses this is there actually isn't just one database. There's multiple ones. And the one you use depends on the environment. So what's an environment? Development, that's your environment of when you're pounding out code on your laptop. Production, that's the golden environment that you must not touch, because if you break it, people will be mad. And test is an environment that only exists for the purpose of running automated tests. Don't confuse this with an environment where you get to do your own manual poking and testing. That's development. The testing environment exists and is managed entirely by the testing tool. So, and by the way, you can define more environments beyond these three. For example, a lot of companies define a staging environment, which is servers that are in the production environment, but they're not visible to real users. It's basically almost, it's like live in every way, except that it's not live because the end users can't see it. But it's the closest thing there is to really running on a system with all of the same conditions in place as if it were a live deployment. So how do we make changes to the database? Because one problem is as soon as you say we have multiple databases, then we got to make sure they stay in sync, right? Any schema changes, any structure changes that I make in development eventually have to make it to production and maybe also have to be tested in a staging server. And my testing tools have to know about them. So we do this with migrations. And a migration really is just a script describing the changes you're going to make. So rather than using your favorite SQL database GUI to add columns and move columns around, we will write code that describes the changes we want to make. We can version that code because it's actually Ruby. And once we've satisfied ourselves that the changes are legit, all we have to do to apply the same changes to the production environment is run the same script over there. That's the basic idea. So why would you do this? First of all, you can identify each migration. You know at what point in time each schema change was made. And like code, you can annotate why that migration was done. Why did we have to add this column? Why did we choose to delete that column? Some migrations can be created to be reversible, which means here's a set of changes I want to make, but actually all of these changes are undoable. And one thing that you can do is in development, if you apply your migration and it turns out to be a mess, you could say, oh, undo all of that, right? And you're doing it in a principled manner, not in a sort of manual way where you have to remember what are the 8 things I clicked on in trying to make this change. You can manage them with version control. And because you can automate them, it's reliable, right? You can repeat it. You can run the migration multiple times on multiple machines, and it will have the same effect. So the theme here that we're seeing with the happy dancing robot is don't do it, automate it, right? If you're thinking about doing it, stop and start thinking about what kind of a tool might I be able to use to automate the task I'm about to do so that I can do it repeatably and track each time I do a change why I did that change and what it is. So let's take a look at a migration. Remember we said that the idea of generating code is pervasive throughout Rails. Here's another kind of code generator. This kind doesn't write new code at runtime. This kind generates code in files that become part of your development environment. So what happens when we issue the command Rails generate migration, and we give the migration a symbolic name that hopefully represents what it wants to do? We're going to create a migration that creates the movies table that I use as an example, a really simple version of it. So let's see what that code would look like. So here's, now when you say Rails generate migration, what you get is basically empty methods up and down, and you've got to fill in what goes into those methods. So what are we doing in this method? Well, we're going to create a table called movies, And in that table, we're going to have a string for the movie title, a string for the rating, a longer text field for the description, a date time field for when it was released, et cetera, et cetera. And timestamps, as we'll soon see, is a field that if you add it, Rails will automatically manage it for you to indicate what was the last time each record was updated or when that record was added. So this is the up migration. The up migration is I'm making a change to go from version n to version n+1 of my database schema. Right now, for us, version n is there's nothing in the database. Couldn't be simpler, right? And at the end of this migration, there'll be a table that has these columns of these associated types. What would be sort of the opposite? How would we reverse that migration? Well, since the migration consisted of creating a table, dropping the table, meaning deleting the entire table, would be the opposite, right? And that's nuclear. You'll drop table. SQL gives you enough rope to hang yourself, and this will become a drop table in SQL. The table will be incinerated. Of course, you backed up your apps, and you back up your databases nightly, as we'll talk about later in the class. So if that happens, you're still not totally hosed. So now this is what the code looks like, right? I've created the migration. I filled in my up and down methods saying how I'm going to change the database, how I would undo that change. But we haven't actually done anything yet. We have to run this code in order for the database to be updated. So we've just created the migration, but what we say is we haven't applied the migration yet. So we're on our development box. We say rake db:/migrate. That will run the script and ideally, in an error-free way, make those changes to the database. Now, we showed a really simple migration, but as the course goes on, we're going to show much more complicated migrations involving adding new columns, creating columns based on the values of existing columns, and many, many other things. But remember, we're still in our development environment. Now we've tested our code. We know that, yes, the migration works, does what it's supposed to do. Now what do? We've got to push it to production. No problem. You just run the same command, but you run it against your remote Heroku instance. That's it. You've debugged the process by which it's done, and then you push a button, and automation takes over. A nice thing about the way Rails manages migrations is that when a migration runs successfully, it also records in a special database table which migrations have already been applied. So in fact, you can run rake db:/migrate over and over again, and it's idempotent. Running it many times is the same as running it once. You could apply migrations to, and when you run it, it actually means apply all pending migrations that this copy of the database hasn't seen yet. And the database itself knows which ones it already has seen. So it's a really nice way of not having to keep track of, I have a staging environment and I have production. Did I already apply the migration in staging? I'm not really sure. Doesn't matter. Just run rake db:/migrate, and if you had already applied it before, then it'll do nothing. Safe times. So we're starting to develop a cookbook of how you do various things in a Rails SaaS app. And the first one is, how do you add a new model? Because to add functionality to your app, you have to add models, views, and/or controllers. And models are the thing that we're discussing first. So when you want to add a new model, or if you want to change or add attributes to a model that you already have, meaning that it already has a corresponding database table, but you want to make some changes to it, either way, you first create a migration that describes the changes you want to make. Give it a semi-meaningful name if you can. Apply the migration with rake db:/migrate. Make sure that all is well, all of your tests pass, and so forth. Once that's been done, and if it's a new model, meaning you haven't used this type of model before, you also need to create a file that contains the actual code for the model. And we showed a really simple example. Like, what is the simplest active record model you can have? It's one that inherits everything from active record and has no logic of its own. Now, if your app contains models like that, you probably shouldn't be using Rails. It's too heavyweight for what you want to do. But generally speaking, you should at least have somewhere in your models directory a model.rb file whose name is the singular version of the database table, right? So there's the correspondence, right? You have the singular name is used for the class, uppercase. Singular name is used for the file name, lowercase. And then the pluralized version, lowercase, is used for the database table. And one thing that people often forget to do, and they're very confused when they just successfully apply to migration, and now they try to rerun their tests, and the tests start failing all of a sudden. Well, remember I said there's actually at least 3 environments that come standard, and one of them is the test environment. Testing gets its own copy of the database that is totally separate from development, totally separate from production. And the reason for that is, by their nature, tests can be destructive, right? You need a database where the tests can not have to worry about screwing up important data. But you have to separately make sure whenever you change the schema, db test prepare is essentially the equivalent of saying, hey, test environment, I've applied new migrations to my database, so just clone the schema that I have and make sure that all the tests see that new schema in the test database too. So again, it's a piece of automation that lets you not have to worry about doing this manually and actually sort of keep everything in line.